Okay, hi and welcome to a question on how to solve a linear system by elimination. Let's get right down into it. Remember, there's two main things that we need to check before we can do our actual elimination. One is that we have like term columns, meaning everything that is a like term is lined up over each other, meaning x is over x, y is over y's, equal sign over equal sign, and constants over constants. And then the second thing that we need to pay attention to before we can eliminate is that we have the same and opposite as long as we're thinking of this as addition. For subtraction, it's a little bit different. All right, so for like term columns, do we have that? No, we just kind of previewed it. We do. We have x's over x's, y's over y's, equal signs over equal signs, and constants over constants. So in this example, we do have like term columns, but what you'll notice is that neither of our two variables have the same and opposite coefficient. So this is a 2 and a 10 for the x's, so those are not the same and opposite, and a 5 and a 3 are also not the same and opposite. So no, we don't have it. So for this example, we're addressing ones that are in columns but are not the same and opposite. So I like to draw these in visually just because it makes me feel better about having my columns. These are the columns that I'm adding down. I know they're a little slanted, but that's just the way the formatting is. So looking at these, I need to pick one of these sets of variables to manipulate so that the coefficients are the same and opposite within a column, or for like terms. So I can manipulate the y's or I can manipulate the x's. The smarter choice is to manipulate the x's here, because all I have to do to get these to be the same and opposite is do 1 multiplication to 2x, or the whole equation of 2x, because I'd have to multiply that whole thing by -5. And again, since this is an equation, what I do to one side I have to do to all sides, meaning that I have to multiply or pseudo distribute to all of the terms. Basically, every term has to be multiplied by -5. Okay? In doing that, what I'm going to get from that multiplication is this is going to turn into -10x. And that's what I want, because now this column will drop out, it will turn to 0. And that's our plan for elimination, is to get one of the columns to turn to 0. So let's go ahead and do that multiplication. So -5 times 2x is -10x. -5 times positive 5y is -25y. My equal sign drops down, and -5 times -22 is positive 110. All right, I'm going to replace the other equation below, just because I like them in the same order as they were. I could draw the line and we could just add from there, but I like to rewrite it. So now we've got our two equations set up. So check on the same and opposite, because now the column of x's are the same and opposite, which this is our purpose for that, is to have that drop to 0. So let's continue our addition here. So we're going to add -25y plus 3y, which is going to give us -22y is equal to 110 plus 22, so 132. If we do a quick check, 132 divided by 22 is going to give us 6. So I'm going to go ahead and divide that -22 now, and y will be equal to -6, because that 22 is negative. So we have the y coordinate at this point for our solution. Remember, our solution is a point, so we can choose to plug this into either equation. It matters not. So we'll pick the bottom one, looks just fine. So I'm going to go ahead and start over here. So I'm going to write 10x, because remember, y is now equivalent to -6. So wherever I see the y, I'm going to replace it with -6. That's called substitution, equal to positive 22. So let's clean this up a bit. So 10x minus 18 equals 22. And now I can start my solving process. Remember, addition and subtraction should be first. And I'm going to go ahead and add the opposite of 18. So I'm going to add that to both sides to keep the equation true. So 10x is equal to 40. And now I'm going to divide by 10 on both sides. And x is going to be equal to 4. So the solution to this system is the coordinate point for -6. Okay, and our next example here for solving by elimination is we've got these two linear functions here. What we need to check again, remember, is one, do we have like term columns, meaning that all of our like terms are lined up over each other, and the equal sign over the equal sign. Additionally, we also need to make sure, because we're thinking of this as addition, right, that we have the same and opposite for one column of the like terms, one of the variables, the x's or the y's. So let's check that. So let's see if we've got like term columns. So like term columns then, I'm going to notice I've got x's over x's, great start, but you'll see that technically I have a y over an equal sign, so that's not going to work for me. And then if I look a little closer, this is in standard form here. This first equation is in standard form, where this equation is in some various form, nothing particular. I prefer to work within standard form, so I'm going to take the second equation and rearrange it. To get it into standard form, I need to solve for my constant, which is this -4, which means I need to move the 7y term away from it. So I'm going to use my properties for equations and keep it true by adding 7y to both sides. This turns into 0, which means it's not on the right anymore. And if I rewrite this, it should look like 10x plus 7y equals -4. And that would provide me a standard form, so they should be in like term columns now. So we can go ahead and check that off. Let's rewrite the other equation, linear equation below it. There we have it. And now we're in like term columns. Now we need to check to see if we have the same and opposite in one of the columns. But first, let's go ahead and draw this in so we can see our columns. Here are our columns, equal sign over equal sign, and constants over constants. So do we happen to have the same and opposite within one of those columns? Well, we've got 10x and 15x, so that's a no. And we've got 7y and 3y, that's also a no. So at this point, we need to pick one of the two columns to multiply to change them into a number that they both can be the same and the opposite. I can work with 10 and 15, but they're going to get rather large rather quick. So I'm going to choose to work with the 7 and the 3. So I need to change that 7 into a value that this 3 can also become. So you'd want to choose the smallest value. In this case, I'm going to multiply by 3 and say that I'd like both of them to turn into 21. So I'm going to multiply all the terms in the top by 3. Now, what am I going to multiply the bottom by? I'm going to multiply it by 7. But I need one of them to be the opposite. So I need to choose one. It matters not which one. So I'm going to choose the top one to make that a -3. Now what I should get, planning this out, is this turns into -21y, and this turns into a positive 21y, and that column will drop to 0. So let's make that happen. So I'm going to go ahead and distribute all terms on both sides of the equations for both numbers here. So 7 additionally needs to be multiplied to everything. So let's go ahead and write that out. So 3 times, or -3 times positive 10x is going to be -30x. -3 times positive 7y is going to become -21y. And -3 times a -4 is going to become positive 12. Okay, so additionally, I'm going to multiply all of the terms on the bottom by 7. So let's go ahead and do that. 7 times 15x gives me 105x positive. 7 times positive 3y is going to give me my positive 21y that I'm looking for, and 7 times 9 is going to give me my 63. All right, I'm going to go ahead and add these down. I'm going to get a -30x, and a positive 105 is going to give me 75x. These are going to turn to 0. That's what I wanted to happen, and that's going to be equal to, it looks like 75. Again, look at what we ended up with by doing our elimination through addition. We've got one equation by combining them that has one variable, so we can solve. And that's a pretty simple solving. X is going to be equal to 1 by dividing on both sides. This gives me part of my coordinate point that is my intersection for my solution. I do need to take this now and plug this back into one of the other two equations, the original ones preferably, to find out what my other coordinate is going to be, or what y will be. So I'm going to choose the one on the bottom. So I'm going to take 10, and instead of writing x, because x is now 1 or equivalent to 1, I'm going to write 10 times 1 equals -4 minus 7y. So I'm going to clean this up. 10 is going to be equal to -4 minus 7y. And again, now I'm solving for this y value, so I'm going to go addition and subtractions first, and then multiplication and divisions after that. So I'm going to go ahead and move this 4 by adding 4 to both sides. So I get 14 is equal to -7y. And now I'm going to go ahead and do my multiplication and division, and I'm going to divide by a -7 and divide by a -7. So this will result in -2 is equal to y. Now the solution then to my system is going to be the coordinate point 1, which is the x-coordinate, -2, which is the y-coordinate. Okay, we've covered how to solve by elimination if our columns are set up and if we don't have same and opposite like terms. All right, if you need more help, see me in class. Goodbye.